Welcome friends, let us continue to study heat engines on my YouTube channel. Kindly like, share and subscribe my YouTube channel. The topic included in today's lecture is numerical. An engine operating on ideal diesel cycle has a maximum pressure of 44 bar and maximum temperature of 1600 degrees Celsius. The pressure and temperature of air at the beginning of the compression stroke are 1 bar and 27 degrees Celsius. Find the air standard efficiency of cycle. For air, take gamma is equals to 1.4. So data, that is the diesel cycle is given. So this is the PV diagram for the diesel cycle. Now the maximum pressure. So maximum pressure is either 2 or 3 because it is a constant pressure process. So P2 is equals to P3. 44 bar. Maximum temperature. So it is the end of the heat supply, that is T3. That is 1600 degrees Celsius or 1873 Kelvin. Pressure and temperature of air at the beginning of compression. So where is the beginning of compression? Yes, point 1 is the beginning of compression. So it is P1 1 bar and T1 27 degrees Celsius, that is 300 Kelvin. Gamma is equals to 1.4 and we have to calculate the air standard efficiency. Now this is the equation for the efficiency of the diesel cycle. We require value of R, gamma and rho. Gamma they have given 1.4, but we don't have the value of R and rho. So we have to calculate these two values to calculate the efficiency. Now let us use the process number 122. Relationship between PV and T. T2 by T1 is equals to P2 by P1 raised to gamma minus 1 upon gamma, that is equals to V1 by V2 raised to gamma minus 1. Now we know that V1 by V2 is the compression ratio, that is R. So we want to calculate R. Gamma they have given us. Now let us see what they have given you. Whether they have given T2 or T1? No, we don't have both the values. Whether they have given you P2? Yes, P2 44 bar you have. P1 1 bar you have. So we can use the equation P2 by P1. So that is P2 by P1 raised to gamma minus 1 upon gamma. That is equals to R raised to gamma minus 1. And therefore P2 by P1 raised to 1 upon gamma, that is equals to R. That is the compression ratio. Now P2 44 bar, P1 1 bar. So R is equals to 44 by 1 raised to 1 upon 1.4. On calculating, R is equals to 14.92. So we have got the value of R. Now we have to calculate the value of rho. That is equals to V3 by V2. So now again for the process number 2 to 3, that is the constant pressure heat supply process. What is the relationship between PV and T? That is V by T is constant. So for process number 2 to 3, we can write V2 by T2 is equals to V3 by T3. Now we want to calculate V3 by V2. So the V3 by V2 is equals to T3 by T2 is equals to rho. T3 given in the numerical, T2 not available with us. So we have to calculate it. So again using the relationship between PV and T for the process number 1 to 2. T2 by T1 is equals to V1 by V2 raised to gamma minus 1. Where V1 by V2, that is R 14.92 we have. Putting the value, we are going to get T2 by T1 is equals to 2.9482. So T2 is equals to 2.9482 multiplied by T1. And calculating, T2 is equals to 884.46 Kelvin. So we have got the value of T2 also. So substituting this value, we can calculate the V3 by V2. So rho is equals to V3 by V2 is equals to T3 by T2. On calculation, rho is equals to 2.12. So now we have got the value of R, 14.92. We have got the value of rho, that is 2.12. Gamma given in the numerical. So using this equation of efficiency, we can calculate the air standard efficiency of diesel cycle. Substituting these values, and on calculation, efficiency is equals to 59.7%. Now let us solve the another numerical. An 8 standard diesel cycle has compression ratio of 16. The pressure and temperature at the beginning of compression stroke is 1 bar and 20 degrees Celsius. The maximum temperature is 1431 degrees Celsius. Determine thermal efficiency and mean effective pressure for this cycle. Data, diesel cycle. So this one is the PV diagram. Compression ratio, that is R is equals to V1 by V2 is equals to 16. Pressure and temperature at the beginning. So it is at point number 1. So P1 1 bar, T1 20 degrees Celsius. So that is 293 Kelvin. Maximum temperature 1431 degrees Celsius. So it is at point 3. So T3 is equals to 1431 degrees Celsius. Converting into Kelvin, it is 1704 Kelvin. We have to calculate the efficiency, and for that we require R, gamma and rho. R given, gamma not given, so we can assume gamma is equals to 1.4. So now we have R, we have gamma, but rho, that is cutoff ratio, not given. So let us calculate the cutoff ratio. Again, for the process number 2 to 3, that is constant pressure heat supply, V2 by T2 is equals to V3 by T3. Therefore, V3 by V2, that is equals to T3 by T2, that is equals to rho. T3 given in the numerical, T2 we have to calculate. So T2 can be calculated using the relationship between PV and T for the process number 1 to 2. T2 by T1 is equals to V1 by V2 raised to gamma minus 1. V1 by V2 is R, that is 16. So it is 16 raised to 1.4 minus 1. So the answer is 3.0314. So T2 is equals to T1 multiplied by 3.0314. So that is equals to 888.21 Kelvin. So using this T2, we can calculate the rho. So rho is equals to V3 by V2, that is equals to T3 by T2. On calculation, rho is equals to 1.92. So now we have got the rho, we have a value of R, and we have the value of gamma, that is 1.4. So we can calculate the efficiency of diesel cycle. Substituting the value, efficiency of diesel cycle is 61.78%. Now calculating the mean effective pressure. The equation for the mean effective pressure is work done in kilojoule per kg divided by swept volume in meter cube per kg. So we have to calculate work done and then swept volume. Now for work done, we know that efficiency of diesel cycle is equals to work done upon heat supply. Efficiency we have, work done we want to calculate, so we have to calculate the heat supply. Once we calculate the heat supply, then we can calculate the W. Now heat supply takes place during constant pressure process, and the equation is mCp delta T, that is T3 minus T2. Mass is not given in the numerical, take 1 kilogram. Cp is not given, so assume that is 1.005 kilojoule per kg Kelvin. T3 given in the numerical, T2 already calculated. So substituting the value and calculating, QS is equals to 819.87 kilojoule per kg. It means we have calculated the QS, efficiency of diesel cycle we have. So we can calculate the W, that is work done. So efficiency of diesel cycle 0.6178 is equals to W that we want to calculate divided by 819.87, and therefore W is equals to 506.52 kilojoule per kg. So for the mean effective pressure, we have calculated the data for the numerator, that is work done in kilojoule per kg we have calculated. Now we have to calculate the swept volume. Swept volume is V1 minus V2. So we have to calculate V1, then V2, and then we can calculate V1 minus V2. What we have given, that R, that is V1 by V2 is equals to 16, they have given. Right? Now what is the equation or the basic equation? P1 V1 is equals to MRT1. P1 given, yes. V1 we want to calculate. Mass is 1 kilogram. R not given, so we can assume T1 is given. So V1 is equals to MRT1 divided by P1. Assume R is equals to 0.287 kilojoule per kg Kelvin. Now P1 is in bar, so we have to convert into the kilopascal. So P1 is equals to 1 into 10 raised to 2 kilonewton per meter square. So putting this value, we can calculate the V1. So V1 is equals to 1 multiplied by 0.287 multiplied by 293 divided by 100. So we are going to get V1 is equals to 0.841 meter cube per kg. So now we have V1. We have V1 by V2 is equal to 16. So we can calculate the V2. So V2 is equals to V1 divided by 16. So it is 0.841 divided by 60. And the answer is V2 is equals to 0.05256 meter cube per kg. So we have calculated the V1, we have calculated the V2, now calculate the swept volume. And the answer is 0.078844 meter cube per kg. So we have calculated the swept volume in meter cube per kg. We have already calculated the work done in kilojoule per kg. Substitute these two values in the equation of mean effective pressure. And calculating the PM, that is the mean effective pressure, is 642.43 kilojoule per meter cube. And that is equals to 642.43 kilojoule means it is kilonewton into meter divided by meter cube. Meter cancel. So answer is kilonewton per meter square, that is kilopascal. So the mean effective pressure is 642.43 kilopascal. Kindly, for any queries, use the comment box. Kindly like, share and subscribe my YouTube channel. Thank you.